Hi everyone, Dr. Tracy, and this week's topic is inheritance and polymorphism. This very interesting topic goes immediately in line with everything we talked about with classes in the previous chapter. Inheritance and polymorphism defines relationship between classes, base classes and derived classes, to share and inherit data and behavior from the base class. Polymorphism allows derived classes to behave in different ways or executed in different ways according to the needs of that class. So, if you want to look at inheritance and polymorphism, it is important to understand this analogy. Okay, when we talked about classes, we talked about classes as being blueprints that were able to establish the methods and properties that would be associated with an object. And every time that object was created, it would always have certain methods and properties that were associated with it, private data members and member functions. So, now, this topic lends itself to add to the discussion of what classes are. Using this analogy, if we defined a class called a vehicle, we could say that all vehicles have headlights, gas tanks, engines. All could be turned on, moved forward, stopped, and we can establish the instantiation of a vehicle. But now there's certain things about motorcycles. While it is included that they are a vehicle and they share all of those things I just said about being a vehicle, motorcycles have particularly limited to the number of wheels they have, which makes them different from a car. And a truck, while it's similar to a car in many respects, it has a pickup bed, which makes that different. Now, a car itself might be a sedan or an SUV or a sports car even. But in each case, there are some commonalities between these objects, and there's also some differences. So that idea is what inherently leads to this concept of inheritance and polymorphism. The substitution principle states that you can always use a derived class object when a base class object is expected. That means if I am running a program that needs a vehicle class, I could use an SUV class. I could use a motorcycle class, as long as there are stimulations in that. When you create a class or that defines an object, you can create a derived class based on the base class. And then you can use this as an object. We see this example with iStream. iStream is made up of iString stream, iFstream, iOstream, and each one of those are base classes, and the derived class, iStream, comes from all of its base classes. Another example in the book talks about a quiz. A quiz has a question has a correct answer. So if we create an example, we have a question, but all the questions can be made up of different things. There are some questions that have fill in, some have choice questions, some have numeric questions, some are short answer questions. But if we look at the hierarchy, we can define a class about a question and then further refine that class based on the type of question it is. This is an example of a base class and derived classes. Multiple choice questions can be derived from that. So when you want an object, first you decide what that object has, that all objects that are question objects would have to have. Probably that's question text, correct answer, point value, something like that. And then we go through to define what they can do. Here is some sample code that would define a class called question. It says that maybe every question should have the text, which is the question, an answer, check to see if the answer is correct, and we need something to be able to show it on the screen. So it has a text and the answer. Every question has a text and the answer, whether it's short answer, multiple choice, fill in the blank. So now when you run this program and you create a question, then you just run the question function, and that's going to run and create a question. We want to be able to have text. We want to be able to have a correct answer. We want to be able to check the answer, and there's the code to do that. Now, when you get into creating a different question other than you set a text, set an answer, find the response. But when you want to do something that has additional values that are necessary, like get a line, you would establish those changes and create a new class based on the original class. Another example is a guitar is maybe derived from an instrument. An acoustic guitar may be derived from a car. So, guitar. So when we create derived classes, is you create a class that inherits all the data and functions from whatever the base is. So in the question example, everything that a question is plus this stuff is kind of what that means. In the example that had to do with vehicles, everything a vehicle is plus this particular thing. So we write it like this using a colon to show that this choice question has everything that the question class has, which is public. It has all of the public functions of question, but in addition, it has something else, and that denotes inheritance. So that's where inheritance comes from. Oh, typo, ignore that. Inheritance is what it's supposed to say. So when you create a program, you might have something that is multiple choice. And when you establish that, you say, I want it to have all of the things that the question has, but it has a different function. So now this creates an overriding member function, which is going to add choices to have multiple choice. And so when you look at this, it's made of multiple parts. By using derived classes, we are able to create questions that can all function like questions, but can be replaced. Creating a quiz that's going to use multiple choices with a short answer. So when you were writing a choice question, the member functions directly access the choice question member data, but cannot access any private data members from question. So this is an example of choice question that requires an add choice function on top of what the question requires. There's a practice that's in the chapter. Take a look at that. The reason why we keep private inheritance, if you do this, here's a class has an error, but notice that here, this is what it looks like if you were going to also have private inheritance. Because private inheritance says you can address data directly from the private section of the class, but it can produce an error. So if you do not specify public inheritance, you get private inheritance, which might compile in an error, and it also could leave data unprotected. So I'm going to skip through this so we could get to overriding member functions. So display the text, display the answer choices is a function, but if we wanted to change the way that the display looks, we could create a new function. If you have a derived class, then a new function will override any member function. In this example, the question's display is prefixed with the function named question to show that's where it came from, and it can display the answer choices. But using choice question, we may have a different function to run that as well. But anytime you want to call back the original member function, we do preface it by the class and 2 sets of colons to show where that came from. Look at those examples. Polymorphism comes when, and I'm skipping to it, but polymorphism is where we create problems that look the same in structure but perform differently. So the display of a short answer question may be completely different than the display of a multiple choice question, which may be completely different than the display of a fill in the blank question. But we want to create a display function for each of them. We just override it. And so that's what's happening with the display program. We want to be able to have a text that have a question that holds text, holds an answer, but might display it in a different way. To access objects from different classes, we use a hierarchy. And if we are promoting the use of objects with as parameters are into functions, we can use pointers to point to objects to base and derived class so that we don't have to create multiple objects that perform the same thing. So to manage all these, we might have a vector of objects that points to questions, but then also contains whichever of the types of questions there are. These derived classes have everything that a question has, plus they have the additional things that are either added to or overridden from the base class. Okay, I hope that's helpful. Hope you guys have a good week. And if you have any questions, send me an email. Talk to you soon.